Assalamualaikum warahmatullahi wabarakatuh. In this video, I will continue with 2.3, which is graph of a function. So let's look at to the different types of graph here. So the first one, we have linear function, which is in general mx plus c. So we have two types of linear functions. It's either the slope is positive or the slope is negative. So for this graph, so it shows that when the slope is positive, m is greater than 0. So for the linear function, the domain is from negative infinity until infinity, and for the range is also from negative infinity until infinity. So that is for the linear function. And then let's move on to the second graph. We have a constant function. So in general, fx is equivalent to c. So c is referred to the values of y. So as you can see here, this is the constant graph. So along this line, this is referred to the values y is equivalent to c. Therefore, the domain is from negative infinity until infinity, but the range is only one values here. So when we have the values is only one, we have to write down in terms of set notation like this. So let's say if the values of y here is 1.5, so we have to put here set notation 1.5. So that is referred to the range of the function for the constant function. And then for the third type of graph, we have here identity function, which is fx is equivalent to x, meaning that every values of x, you will have the same values of y. When your x is 0, y is also equivalent to 0. When your x is 2, your y is also equivalent to 2. And the domain for the identity function is from negative infinity until infinity, and for the range is also equivalent to the negative infinity until infinity. And then for the next graph, we have a quadratic function, which is in general fx is equivalent to x squared. So this is the shape of the graph. So as you can see here, this is for the quadratic graph. And then in general, the domain is from negative infinity until infinity, and the range will start from the values of 0. And for the values of 0, it must be close bracket until infinity. Next, we have a cubic function, which is fx is equivalent to x cubed. So this is how the graph of cubic function looks like. So we have here with the domain of negative infinity until infinity, and the range is also from negative infinity until infinity. Okay, next we have a square root function, which is fx is equivalent to square root of x. So the shape of the graph will be like this. So it starts from the 0 and until infinity. Therefore, the domain of the square root function 0 until infinity, and the range is also starting from 0 until infinity. Next, we have a cubic root, which is in general the function is fx is equivalent to cube root of x. So the shape of the graph will be like this. For the square root of function here, square root of x, we don't have any values of y when the x is negative. So that's why we have only the lowest values here is 0. But for the cubic root, for the cube root of x, we have here when the x is negative, the function is also defined. So that's why we do have the graph on the left side here. So until infinity. Therefore, the domain here from negative infinity until infinity, same goes to the range from negative infinity until infinity. Between the cube root of function and also the cubic function here, so it is different. So for the cubic function, it should be like this. But for the cube root of function, so we have something like this. So this is the difference between cube root and also the function of cubic fx is equivalent to x cubed. So make sure you know how the basic graph looks like. What is the difference between cubic and also cube root of function. Now let's move on to the next type of graph. We have a reciprocal function. In general, fx is equivalent to 1 over x. So we have learned about how to find out domain for any rational function 1 over x here. So x cannot be 0. So that's why, as you can see here from the graph never touch on the line x is equivalent to 0. So on the exactly y-axis, this is the line x is equivalent to 0. And the graph also never touched the line of y is equivalent to 0. On the x-axis here, this is referred to the line y is equivalent to 0. So the graph is only approach to that x is equivalent to 0 and also y equivalent to 0 on the left side and also on the right side, but it never touched on the reciprocal function 1 over x. Therefore, the domain for the reciprocal function, if the function is 1 over x, so x cannot be 0. Therefore, the domain in terms of interval notation from negative infinity until 0, union 0 until infinity, same goes to the range. Then for the last graph, we have absolute values. Fx is equivalent to modulus of x. So this is how the basic graph looks like. And the domain is from negative infinity until infinity, but for the range starting from 0 until infinity. So you need to remember the shape of the graph for each function here, so that will be more easier for you to answer the question on the piecewise different function and also transformation function.